Hi, this is Ms. Goodman, and I'm going to present 3 problems using scientific notation. In the first problem, we're going to convert from scientific notation to decimal or standard form. In the second problem, we're going to convert a number in decimal form to scientific notation. And in the third problem, we're going to calculate using scientific notation. Let's begin with question number 15. Question number 15 says to convert 6.95 times 10 to the 6th power to decimal form, which is the same as standard form, the way we usually write numbers. Now note that we have 10 to the power of 6. This is a 1 with 6 zeros. That's a million. So we're multiplying 6.95 by a million. So it should get bigger. That means the decimal point should move to the right. And it's going to move to the right one time for each of those 6 zeros. So 6 decimal places. So beginning here, we're going to move 1, 2, 3, 4, 5, 6 decimal places to the right. Now, the first 2 jumps are over the 9 and the 5. And then it hops over these 4 zeros. So we have 6,950,000 for standard form or decimal form. And that is the same as 6.95 times 10 to the power of 6. Question 13. Question 13, we're converting 0.432 into scientific notation. Okay, currently the number is in what's called decimal form. To put this in scientific notation, one of the requirements is that we put the decimal point to the right of the first non-zero digit. And then the other digits follow. The second requirement is that we multiply. And the third requirement is that we multiply by base 10 to the power of whatever will make this number equal to what it was before. So we have to make this number here equal to 0.432. Well, how do we do that? The decimal point was originally here, right here. So to get it back there, we would need to move 1 place to the left. Well, 1 place to the left is -1. 10 to the -1 means divide by 10. It means move the decimal point to the left 1 place. And that's our answer. Question number 14. We're going to evaluate 1.71 times 10 to the power of 4 times 6.36 times 10 to the power of -7 all over 4.54 times 10 to the power of 3. So we want to simplify that. We want to do this calculation. Now, we know we can calculate the numbers by the numbers, and we know we can use the product rule whenever we have like bases. The product rule of exponents applies to like bases being multiplied, right? So we can multiply the numbers and we can multiply the like bases in the numerator position. So we'll start there. Let's multiply 1.71 times 6.36. I'm using my calculator. I get 10.8756. And then over here I have 10 to the power of 4 times 10 to the power of negative 7. Well, by the product rule, when we multiply like bases, we add the exponents. So we're going to add these exponents, the 4 and the negative 7. And down here we still have 4.54. 10 to the third. Okay. Now again, we can divide these numbers. So I'll do that. 10.8756 divided by 4.54. And I get 2.39. They want us to do it to 4 decimal places, so I'm just going to write up to the 4th decimal place. After that 5, there's a 0, so this 5 here remains unchanged. Then I'm going to simplify these signs. 4 plus minus 7 is the same as 4 minus 7, right? Because these are different signs, so it's negative. 4 minus 7 is minus 3. Because 7 minus 4 is 3, but the bigger absolute value is negative, so the answer is negative 3. And on the bottom, I still have that 10 to the power of 3. Okay, so now all I have left to do is to simplify this part. I know I can simplify it because again the bases are alike, but this time the bases are dividing. When we divide like bases, we use the quotient rule, we subtract the exponents. So now we have 2.39. 2.3955 times 10 to the minus 3 minus 3. Okay. So going to the next slide, we have 2.3955 times 10 to the minus 3, that's what we had on the previous slide, and that's the same as 2.3955 times altogether 10 to the negative 6, right? Altogether we have 6 negatives. And that is scientific notation because the point is after the first non-zero digit, to the right of the first non-zero digit, and we're multiplying by 10 to the power of something. So there we have it.